Welcome all together to today's webinar, again hosted by the Open Telecom Cloud community. Today I have brought two guests with me. The first guest is Victor, the second guest here is Ferhat, both from iits Consulting. And today, you can also see it here on the screen, we'll talk about the OTC GitOps with ArgoCD, and we will have here as examples Elastic Kafka, and also many more. You know, you had the possibility to vote for it, and we have chosen the most voted elements for today's presentation here. With this, I would lead over to Victor.
Yeah, thank you very much, Stefan. As an introduction, I don't have much to add. So why did we choose Elastic Kafka for today's talk? That's because you voted. So these are the voting results, and as you can see, Elastic Kafka, Traffic, and Set Manager we will handle today. Together with Ferhat, we prepared everything to deploy today, everything and within 1 hour. What we want to do today then is start from zero and have nothing in the cloud, and then within 1 hour we will have all the services up and running. It's a very tight schedule, but I think we can manage that. Okay. Something about my person. I think most of you guys know me already. My name is Victor Getz. I'm the CTO and founder of iits Consulting, and today I brought with me Ferhat.
Yeah, my name is Ferhat Öztman, and I currently work as a cloud native consultant at iits Consulting, and I'm happy to be here.
I will stop my video share because I have a little bit internet connection issues. Ferhat is working for us in the V project. It's one of our biggest projects. And yeah, so basically we will show the stuff which we're doing in this of the projects. So a small introduction into our company. Our company was founded 2019. We have now over 45 employees already. We are really growing. And our purpose of our company is we provide agile development teams that help business automate their complex products and processes. So basically, if you have something which you need to be developed in Vue, Kotlin, or whatever, or just a business idea, we can fulfill this idea and develop it very fast because we can deliver a team for you. Just to mention, we are also the best employer of Not Failure. We got no award for that. We are Cloud Native Computation Foundation member. We are Elastic Stack partner, a Kubernetes certified service provider, HashiCorp partner, and many more certificates and partnerships. So basically, we know what we are doing. So we wanted to share our knowledge today with you. The agenda for today is very simple. So first we have a little bit reminder of GitOps, and then we have the Terraform stuff. So basically we will boot up everything inside the OTC and create a new VPC, Kubernetes cluster, load balancer, and everything. Yeah, then we switch over to ArgoCD, deploy their Elastic and Kafka. This is the part which Ferhat will do, and I will do the Terraform stuff, and later will be the summary. I will not go very deep into the GitOps theory because last time we had to talk about GitOps. So I just want to have a reminder what the principles of GitOps are. And these are these 4 points. The entire system should be described declarative. The canonical desired system state should be versioned in Git. Approved changes that can be automatically applied to the system. Software agent to ensure correctnesses and alert individuals. And yeah, so in theory, it sounds like pretty cool. Yeah, cool. Yeah. Okay, I know what I need to do, but what kind of software should I choose? Should I choose more ArgoCD? Should I use Flux? How to set up the architecture? How to split it? What is apps pattern and stuff like that? And that's what we will show you today. We will show you today a very simple setup, but this is super effective. So how does it work? We have some example how you can do it, and we use it in a lot of projects because it's very, very simple, very easy to understand. So first we have Terraform, and what we do, we set up the infrastructure, load balancer, Kubernetes cluster, and everything. You can do it on the OTC, but you can do it also in all other clouds. So it's not depending on the cloud. But today we'll do it for you in the OTC and show you how fast you can do it. So after we set up all the with Terraform, all the infrastructure stuff, and we have our database and all the stuff, we connect through Terraform Helm to our Kubernetes cluster. and install and configure ArgoCD with Terraform. This is the next step we're doing. And then we are finished with the Terraform stuff. Then the second step is ArgoCD. ArgoCD, what it does is it installed inside the cluster of our newly created infrastructure, looks at some Git repo, which kind of infrastructure charts it should be deployed. So in this time, today, we want to deploy, for example, Kafka and Elastic Stack. So these two Helm charts are inside this Git repo, which we call infrastructure charts. And then what it does, it looks at the Helm charts, which are laying in this Git repo, and automatically syncs it to our Kubernetes cluster. We call it also pull deployment because we don't go interactive into the cluster, but we're pulling all the information from a Git repo, and the cluster itself is responsible for deploying all the information into its Kubernetes cluster. The benefit from that is security-wise super cool, because you don't need to provide Kubernetes control and everything. And basically you can make changes just with git commit and push. You don't need any tools, nothing. Okay, maybe you are like, yeah, cool. Now I have Kafka, Elastic Stack, but what about my business services? What about my Vue.js or Kotlin application? It's the same, but we separate them. So basically we have some a Git repo where the app charts are inside, and we have one Git repo for the infrastructure charts. It's also better for permission and control. For basically, maybe you have one team who is dedicated for infrastructure and one is for the microservices responsible. So you want to split it. So we have a different Git repo, which we call app charts, and there we have some Vue.js or Kotlin applications, for example. So this is the main takeaway for today, this picture. And now we'll show you how to do it in a practical way. So now it's time to Terraform. We will start today with you from a completely blank cloud. And what I will do now here, I will go and create first myself a Terraform user, because I need the access key and secret key. So I go here, say create user, and then I say here, for example, Friday talk. I say it's a programmatic access, and then say next. For today, I give him just full admin permission. In your case, you need to adjust the rules. And now I can download here the access key. And then I have here my access key and secret key. And what I do now is we have a lot of open source code in the iits company. So basically there's here project factory from OTC. And here you can use many of our wisdom and our code to deploy your stuff. So we have some incubator project here. And what I did now is I just have here an empty project with a simple README, which walks you through how to set up the infrastructure, which I will show you now. And this one is all public, yeah. So basically, if you go here to our iits GitHub, you will find all the projects here. So if you want to replay what I did today, you can do it very easily. So we have here every time the environment variables which we need. So we need the access key, we need the secret key, we need here to put the domain name. So basically on which cloud we are working on. Do we work on EUDE or an EUNL? Maybe we have a sub project. So basically you're free to choose. What we use every time ETS, we have some context name and a stage name. So basically the context name would be your customer or maybe your business project name for, and the stage name is like the typical staging, dev, QA, production, infrastructure, end-to-end testing or whatever you want. And we have also here in our project factory, we have also full description on also a detailed view how to set up this with Terraform. So what we have else, we need for ArgoCD, we need the pull secrets and we need the Docker config, because we're booting up some containers, and to boot up ArgoCD, we need a Docker config base 46 encoder because of the Docker hub pull rate limits. And today we will work on GitHub. So basically this environment and variable I don't need. And I will now replace all of the secrets here so that we can start working. What I will do now is I will once shift it to another window because there are really some secrets inside there. We'll source it once and then we'll get back to you. I need the Docker pull secret. I need the access key, which I just created 2 minutes ago. I created 2 terminals and sourced, I replaced the values and sourced this environment variables. And now I can start working. I use 2 terminals because we are very fast. And so basically we do some things simultaneously. The context for today, I would just call it Friday. And the stage I'll call dev. So I will create here a new folder and to name it Friday. And then I want to have a new stage. But first we need to create a remote state bucket. So there I go use again our description here, and here's a description how to set up a secure remote Terraform state, and that's what I will use now. So I'll copy here from our incubator project, and what it will do, it will create for us an OBS bucket, and will encrypt it by default. So basically, if you put anything inside there, it will encrypt it automatically. All this code and everything is inside this Terraform project factory, so you can just reuse it. And also I will commit and push the code, so you have everything. So Terraform init, Terraform apply, and it will ask me for the bucket name. So today we have Friday, stage is dev, TF state, for example. Ah, yes, no. If you do. So now we create the remote bucket. And what we do now is after we created it, we need to set up the infrastructure. So basically I'm copying also from our incubator project, I'm copying these modules. What are inside these modules? We have a SSH key pair for the nodes. We have a virtual private cloud. We have a CCE, a load balancer, and we have also an encrypted S3 bucket where we put all our dynamic Terraform information inside there. If you use HashiCorp Vault or some other secret mechanism, I would switch it, but it's really easy to use and really easy to understand if you use, for this case, a bucket. But we use normally HashiCorp Vault for that and to give the information over to HashiCorp Vault. You saw I applied this one now. So basically it creates for me this backend S3 config. And this one I need to set here. Here's a placeholder, replace me. So I put it here inside. And here I have some more variables, but we have already all the environment variables. So basically we can start directly. So I go into Friday, dev, Terraform init. Copied into the wrong folder. This bad. So downloads me all the stuff. And we'll create now Kubernetes cluster and everything for us, and put all the information inside there. So make Terraform apply. And it should show us a lot of stuff. You see here, these are all remote modules from us. So you can steal everything if you want to use it for your project, get some inspiration how to do stuff. All the modules are also, you can use it for projects also. They work on EUNL and UDE, and so basically it should work everything. So 15 items we want to add, and he starts the creation. And during he creates everything, I will switch back to our slides because it will take some time to boot up everything. What we will do next, what we need to do is we need to deploy ArgoCD, and we need to tell ArgoCD to which Git repo it should take a look. Why do we deploy the stuff with Terraform? Because you have the secrets which you automatically can inject then into ArgoCD, and yeah, so you have a very fluent flow. So you can rebuild the cluster with one click, and you have like hundreds of containers online. So what we do, we split up the ArgoCD configuration from the ArgoCD itself. so that it will not become a ball of mud. So in the ArgoCD configuration chart stays where we should look, to which Git repo, and yeah, the credentials are inside there. Yeah, and so it's really project depending stuff. And the ArgoCD itself, the second part, is independent, and it's just a plain ArgoCD installation. What we will do now is we will install first some custom resource definitions so we don't have this hen-egg problem. We will store registry creds, which auto-injects Docker Hub pull secrets and auto our container. We'll deploy the ArgoCD config and the ArgoCD. Go back to our Terraform. And we copy also from our incubator project, we copy a Kubernetes folder. Inside this Kubernetes folder, we have the elements which I just showed. So basically, reusing the secrets from the first step. So this bucket, we reuse here the data and read from there and use it then here. So we have here custom resource definition. We have the registry creds, ArgoCD configuration chart, and the ArgoCD chart itself. And we need for sure the modules, because ArgoCD is very So we have here the modules, and we have here ArgoCD and the configuration chart. And the ArgoCD itself is like really independent. So we have just here some basic Europe time zone or something like that set. But here inside our configuration chart, there it becomes very, very dependent. So we have here values.yaml, and we have for our ETS guys, we have every time some this incubator project and some to-do markers. So basically we need to adjust this one. So we have an infrastructure project, so just infrastructure parts. So the naming, this one is correct. This one is not correct because we have a different repo. So I will take a look here. What's the name? I think it was something OTC chart. Here it is. Showcase OTC charts. I'll copy this URL. This is the stuff where Ferhat will put all the charts then later, which should be deployed. And here we have also some templating. So basically we have here some variables for the stage, which will be replaced. So it's just a placeholder to be more dynamic. Okay, so here we have also Git token. Terraform is the name. Password is also good because we're using GitHub, so we don't need to change anything. If we would use GitLab, we need to add it here. Yeah, the templates, we have here route later for ArgoCD. Here is the infrastructure configuration. Seems everything fine. So inside our stage, we have here Kubernetes folder because we split the state into Kubernetes and our infrastructure. That means that we need here to define a new backend because we have two states. So I switch here. I will just move the old Terraform state. And we'll say again Terraform apply. And we want to have now for Friday dev neatest TF state. We want to have a bucket. And we say yes. So basically we boot up the infrastructure. Then we have a new Terraform project where we install all the Kubernetes stuff and everything which happens after the CCE is created. So we go here inside the Kubernetes folder and add one. You can see here, this is the difference. Everything is by default encrypted. We have here also bash script, which is a little bit for convenience. And this is a setup which is don't need HashiCorp Vault and all the stuff. So it's a very, very plain setup. In real environment, you would also create a HashiCorp Vault system and stuff like that. But here in this example and with this technology, you can start very, very easily and understand how the things are working. So we take a look here. He's still booting up the nodes. And I will just go into Friday dev Kubernetes. And if I execute the script here, it will just download me from the bucket my Kubernetes config and will print out the public IP. So let's see if it's already working. Yeah, it's already working. So this information Ferhat needs in the second step to connect the load balancer. So what I will do now is I will just send him this information.
Yep, thank you. I just received that.
And here we need to wait. We're a little bit faster than the nodes are creating, but it will take like 2 minutes more and then we're ready to go. So we can press here already Terraform init and the Kubernetes. Why we cannot do yet because the nodes are not still up. So we need a little bit, wait a little bit more. What it will do now is it will install the ArgoCD configuration chart where we set to which Git repo it should take a look at. And we also give here the GitHub access token, which we set here during the environment variable. So basically, if you use this one, you don't need to configure much because this is the basic configuration you need for OTC to work with all the stuff. So now the nodes are up. So we have everything created. I can show you very quickly on UI also how it looks like. You see here we have a Kubernetes cluster also. We should have a Kubernetes cluster which is called Friday Dev. Yeah, Friday Dev. And now we install on this cluster, we install some Helm charts. So we apply this main TF from the Kubernetes folder and say no Terraform apply. And say yes. In the meantime, what we do, we watch the Kubernetes pods. It's something like Netflix to watch the Kubernetes nodes and pods go just up. Yeah, because I executed this kube control config sh. He put it into my kubeconfig, and that's why we are already connecting to our current cluster. You see here these are very fresh, and also you can see here the nodes are also very fresh. These are our newly created cluster in 2 minutes. So let's take a look. Here, here are our nodes, and it's still creating. It takes a little bit of time because it's a lot of stuff which we want to deploy there.
Yeah.
We can do it even better. So basically we'll have it all on one screen. You see now registry threads are starting. It injects everywhere in every our container. We configure it by default like that. You can also customize how you want it. We inject the Docker Hub full secret. So basically we don't need to care anymore about Docker rate limits. And you see now ArgoCD is also booting up. And what we need to do now is just to connect to this cluster, to the ArgoCD. So I say kube control means an ArgoCD port forward S4C ArgoCD minus server. Was it again 8080 443? Pending, yeah. Because on the left side you can see it's still creating. Now it's there. So let's take a look. So we call here localhost 8080. And voila, we are on the cluster and we can see ArgoCD doing port forward. So now we come then to the next part. Wait, I will switch back to the slides because my part is done. And now Ferhat will take over and deploy some cool Helm charts for you.
Okay, thank you very much, Victor, so far. Yeah, today my goal is to show you how you can easily, or in a quick and easy way, deploy your infrastructure Helm charts using ArgoCD and our infrastructure solution. Yeah, based on our vote, we just decided to deploy today our site manager for our Let's Encrypt certificates, and we want to deploy traffic as our Ingress controller, Kafka, and also the big chunk Elastic Stack. And I hopefully will be able to show you how you can deploy this kind of decent complex Helm charts in a very quick and easy way. What you basically need is a specific directory structure, and this will happen inside your infrastructure charts or Helm charts repository, which will serve as a single source of truth repository for ArgoCD. For that, you just create the infrastructure. I mean the directory infrastructure, as I stated, and we will start by creating our directory stages. From there, we continue and take our stages name, which is in our case just dev, and then we will create the directory for our application, ArgoCD application, and inside that infrastructure charts, we continue with our apps directory, and of course, we need a templates directory. Okay, great. Since the infrastructure charts directory is our application level, I need some additional specific Helm chart for that. For that, I will just copy my Helm chart and paste it right here. And of course, I need also the application itself. And this goes right into the templates directory. Nice. From here, we will start deploying Cert Manager and our storage classes first. So we get the necessary certificates and the PVCs and PVs we need for our deployment. And I will copy those Helm charts and paste it right inside the apps directory. So we are basically doing that because we are following here ArgoCD's specific apps pattern. And for that, as I already said, you need an application, which is called infrastructure charts in our case. And inside that directory, you have an apps directory where you will place all your Helm charts, which you want to deploy. So all you have to do, we don't need all that stuff. If you add a new Helm chart inside your apps directory, you have a values.yaml for your ArgoCD application. And all the newly created or added Helm charts have to be configured inside this values.yaml. So you don't have to go necessarily inside each Helm directory or Helm chart and configure your chart itself. So you can do it all inside your values.yaml. So let me do quickly some adjustment here. Our app base path is basically the path where our Helm charts will be living. And this looks correct. This is wrong. And the repo URL is our single source of truth for ArgoCD. And this is correct as well. So basically, ArgoCD will synchronize all the Helm charts inside that repository with the cluster itself. Okay, we already added the Cert Manager as our first Helm chart, and the second one is storage classes. So I have to define them inside my values.yaml. For that, you just type in Cert Manager, the name of your Helm chart, and you define everything or the configuration which is necessary for your Helm chart. So for the Cert Manager, I only need a namespace, and that should be Cert Manager. And for our storage classes, storage minus classes, we will set the default namespace. So this should basically it. And when I commit and push this on my showcase OTC infrastructure charts repository, ArgoCD will synchronize it and deploy it immediately inside our cluster. Now let's see if we can do that. Storage and sats. Commit and push. Now let me switch back to ArgoCD. And our username is admin, and Victor just sent me the passwords. Okay, wow, bang, it's already there. So this is our application infrastructure charts, and those are our first two Helm charts we just deployed. So our storage classes should be up and running inside the cluster. Yep, looks fine, all green. Excellent. And our cert manager, this could take some more time. Oh no, okay, it's done as well. Great. Well, it's very easy and very fast. Okay, we continue with more Helm charts. And for that, as we said, we will deploy Elasticstack, Kafka, and Traffic. So let me copy those Helm charts quickly and paste it inside the apps directory. So, okay, let me quickly see if I have to do some adjustments now. Okay, it's all set by stage values. So the set by stage values basically tells you, okay, you have to set it at the application level. So if you want to set that value, you have to do it inside the values.yaml from the application itself, which we will do in any time. Okay, this one needs as well a stage value, the elastic. 2. Okay, great. So we will continue here. Let's start with Elasticstack, I suppose. Oh, we go with Kafka. So because this is a bigger configuration for Kafka, we take the namespace Kafka and parameters. We do these. We will set the stage values right here. So we will pass the Helm parameters for that. And the name DNS. No. Quickly just to save time. Okay, and our value is today admin stage ATS take. Okay, looking good. Then we go on with traffic. And take routing, and we continue with the configuration itself. So let me just copy it right here. And Victor sent also me the correct ALB ID. I have to copy that too. So traffic knows which load balancer to use. Okay, great. And what I also need is a specific kind, or ArgoCD specific kind of configuration. That is the ignore differences. Yeah. I have to do a little bit of XCORS here. ArgoCD offers you this option, ignore differences, to ignore differences you don't want ArgoCD to check. So a good example would be with secrets. If you, of course, your secrets inside your secrets inside your manifest on your repository, and compared to the live manifest inside your cluster will differ, because you will inject your secrets after the deployment through a third party like webhook or something else. And ArgoCD will state that difference as an issue and will say your cluster is out of sync with your repository, but that's totally fine, because you will not store your secrets inside your repository. So if you have that kind of specific information which you want ArgoCD to ignore, you have to ignore differences. In this case, we want to, ArgoCD to ignore our metadata annotations from traffic, because that will change, and that is that will change after the deployment, and that is expected. So that's why we have to put the ignore differences for traffic right here, just in case if you wonder. And the namespace is already stated. Okay, let's go on with Elastic Stack. For that, I will just also copy it to save us time. That can go away. The domain looks good. Okay, now just let me quickly review if I have not forget something. Site manager, storage cluster inside. Okay, you have Kafka, we have traffic, and we have Elastic Stack. Okay, looks good. All should be configured. Hopefully I didn't do some typo. We will just commit and push it. Kafka, traffic, and Elastic. No, don't analyze my code, just push it. Okay, it's pushed. Now let's go back to ArgoCD. I'm very excited to see what happens. I will just press the refresh button to stay stuck. Okay, it even was faster than I was. Okay, it's synchronizing.
I think you had a typo in the values.yaml.
Yeah, it can be. It can be because I just typed it inside just to show how we can configure it. This time it can happen.
Line number 24 needs to be a little bit to the left. The ignore differences are not a part of the Helm.
Ah, okay, yeah, that's my typo. Yeah. Okay, that's no big deal.
Yeah.
Okay, that's absolutely no big deal. Just a indentation error. It's okay. Push it again. And then hopefully it should be fine. But as you can see, this is how you basically maintain your code. So if you're a developer, you can maintain the code yourself. You don't have to get the DevOps guys. All you have to do is adjust your code inside your single source of truth, push it, and ArgoCD will take care of the rest. As you can see, now it's all fine. All the Helm charts are just deployed, and your cluster is up and running. Let's see at Elastic Stack, because that should take some more time. Yeah, it's still deploying, so let's just give it some time. And Elastic, what is it? And Kafka should be the same. Okay, it's also still deploying. It's a lot of stuff, and it will take some time. So we just give it some time. Okay, well, in the meantime, as I said, you can, or you have to do all your customization inside your values YAML from the application itself. So this kind of templating is also very convenient, and it's easy to use. And sometimes it can be that you have to do some furthermore adjustments inside your Helm charts in your templates directory, but that would be even more specific. But regarding all the customization for your infrastructure, if there is anything you can template out of your way, you can do it on the application level, and all you have to do is to define everything in your values.yaml. So it's a very nice and easy to use method. See if it's up. Okay, it's still deploying. It takes time. Okay. Looking good. Elastic Stack is coming. Kafka is also looking good. It's coming. It's deploying. Still deploying. What I did here was I did not deploy the Helm charts one by one. What I did was I just copied them and pasted them all at once. I did that on purpose to show you how you can spin up from 0 to hundreds of applications in a quick and easy way. And yeah, all you have to do in this case is just to grab a coffee and enjoy your deployments, which will hopefully be up in any time.
Yeah, Elastic Stack is like a really monster. Yeah, if you looking for a logging solution, Elastic Stack is something which you need if you use it also for business data. For example, we use it for 1 million of addresses to search and query over them, and to use it as a fast response. But if you have a very small application, I would rather recommend the Loki Stack or something like that, which is a little bit smaller. And also, if you deploy this is just a cluster with 16 gigabyte of RAM, and we have now dozens of containers there, and the Kafka system and the Elastic Stack system. So it takes a little bit of time to boot these things up.
Yeah, but Kafka is looking fine. Yeah, Kafka is up and running. Let's see if I can already access it. Main for today, we choose Friday. And it's a minute. It's still not ready.
I think you made maybe not HTTPS.
Yeah, I just wondered. That's why I checked again. Okay, Elastic Stack is also up and running. Great. So all is green. Now you should be able to access it. HTTPS admin.friday.
That def minus.
I forgot the stage. Okay, totally
Exactly.
my fault again. So let's do it again.
Yeah, AKHQ is up.
Yeah, AKHQ. So Kibana is up and running. Great. And now let's switch quickly back to. Yep. So our UI Kibana for Elastic Stack is also initializing. Cool, it's up and running. So wow, I'm impressed myself right now. It started really quickly, even for that kind of a big deployment. Maybe Victor, you can show a bit more with Elastic Stack, because I know you're very experienced with Elastic.
Okay, I will show you some parts, just the basics. And what I just want to show you that it's already collecting logs, and that we have Firebit also installed. We have Firebit, Kibana, and Elasticsearch there. So if you look at my screen, I will just create for you a custom index here. So I go to Stack Management. I have here my index management. You see here there's the default Firebit. Later you group them in different indexes, make cold storage and like cleanup policy and all the stuff. But it's really depending on the project. Yeah? So. Then I'll go here to index pattern, create the index pattern, say Firebit, and yeah, just take here the timestamp, create the index pattern. Then I go here to discover. If you need some custom Elastic search configuration, and there's even like dedicated consultants for that who are working with that. So yeah, it's like super huge, the Elastic Stack. What I wanted to, you can see here also, he collects also the fields from our Kubernetes. So we can reuse all of the fields. And so I say here, I want to have the message, and what would be also cool to which container it belongs to. Yeah. So we take this one also, and you can see here, these are the logs from the Kubernetes. This is from the host system. This is from Kibana. We have here some repository server, which also some other containers here, but Kibana was the latest. But here's also Firebit. So you can see here all the logs, and you can also group here. You can also search for a specific message, like how you want to do it. As I said before, Elasticstack is really huge, and yeah, it's complex to tell everything about Elasticstack. Maybe we need a dedicated talk about how to log properly and how to see and for which kind of purpose, use which tool, when to use ARM, and when to use logtag and such a thing. Kibana was also there. The nodes are also there, so we have a completely working Kibana environment. The Kibana configuration is very close to what we use in production. So yeah, feel free to use it. Yeah, then let's go back to the slides. We have 2 more slides.
Yeah, this was basically it, what I wanted to show. And I have certain things to mention. One big important point, which I already stated, is that it's very easy to that you can, with the setup, spin up from 0 to hundreds of applications in no time. And with our solution, you just saw, I just took Elasticstack, I took Kafka and Traffic, and they were just deployed in no time. And that's a huge benefit you get with our solution. And the reason we chose ArgoCD, and now there is a big discussion between ArgoCD and Flux, but the reason we chose ArgoCD is because of its easy to use nature. So ArgoCD is when you have developers which are also need to configure things inside your infrastructure, or let's say inside your Helm charts, and ArgoCD is very easy to use. So you don't need to be necessarily a DevOps guy to deploy your Helm charts or to do some configuration. And that is a bit more different with Flux. So Flux is a bit more complicated than ArgoCD, which doesn't mean it's bad. This is not what I'm talking about. But if you're not a DevOps guy, Flux, you will hesitate to use Flux. So you will struggle with it for sure. And you have an advantage with your development team that they don't have to wait for the DevOps guys, and the DevOps guys have the advantage. They don't need to be disturbed for every configuration, excuse me, that needs to be done. So every team can focus on their stuff, and ArgoCD will take care of the rest. And because of its easy to use nature, it's a great tool for this purpose. That's why we chose ArgoCD inside our solution. Yeah, what we did not cover today, basically because it would go way beyond the scope of today's Friday talk, is how we can deploy custom businesses using microservices like a Kotlin and Vue. I did not cover a Bastion or a Bastion server or a jump server. So how we can use ArgoCD behind this kind of a high security infrastructure. And of course, we did not cover the CI/CD pipelines and how you can use the Terraform code inside your pipelines. This was also not none of our topic today. And the definitions of of the Helm charts and the Terraform code was also not covered for today. But in the future, if you want to talk about these kind of stuff, we can do it, or you can send us an email and ask questions about those topics.
Yeah, thank you very much, Ferhat.
You're welcome.
Yeah, we managed to do everything. We have 5 more minutes to go. So basically, I just want to say, I just want to show the basics, yeah? And you need to work around, use HashiCorp Vault system. Don't store base 64 encoded stuff in the Kubernetes secrets. Use Vault injections for that or something like that. Use a Bastion hosted jumper. So you need WAF and all the stuff, but it would be way too much for 1 hour. So basically, we wanted to show and focus on the stuff that we can use Terraform, deploy ArgoCD with that, and ArgoCD looks then the Git repos and deploys it. Yeah, for our production environment, we have a lot more complexity, which would be too much to show it. But like this basic, which we're using for clients and for projects where the developers also just deploy their own microservices. And it's pretty cool. It's really cool. Like our developers really loving the setup because they can do and define everything on their own. The routing, they can define on their own. They can set up a new microservices just yesterday, a new microservice was created from one of our teams. And I just asked him, yeah, you need some help? He said, no. It's like super clear to do that. And yeah, so they used it. And yeah, if you have some more question, you can just write us. And yeah, I hope you enjoyed our talk so far. And now I will give over to Stefan.
Thank you a lot, Victor, and thank you a lot also, Ferhat,
You're
for
welcome.
this great presentation here. So thank you, as said, Victor. Thank you, as said, Ferhat. Thank you for all of you who have attended this meeting, this webinar here. Please come and join us in the OTC community to get the notifications about new and future webinars. Thank you a lot, and then we'll see you in the next webinar. Thank you all. Bye.
Thank you too. Bye.
Have a nice weekend. Bye.